when we've been given the cosine ratio in the exact fraction form, what's nice about that is we actually have two sides of the triangle to work with. I have the x side and the radius side. So if I draw this in, I have 5 along the x. It's in quadrant 4, sorry. So it's quadrant 4, so 5 along the x. Okay, and 8 along the hypotenuse or radius. And then I have an unknown side that I have to solve. Okay, so it says solve for theta and find sine and tan. I'm going to do sine and tan first by solving for this third side. So I'm going to go 8 squared minus 5 squared, so 64 minus 25. That's going to give me 39. So I'm going to end up with square root 39 as my radius. Sorry, not as my radius, as my y position. Okay, now mind you, it's going to be plus minus. Now it's important that we recognize that this is positioning. This is not root 39. It's going down root 39. Okay, so our positioning has to have the right sign. Okay, so once I've done that, I'm now ready to write my ratios, my trig ratios. I'm going to write my sine ratio, so sine theta equals, it's a negative sign in quadrant 4. Okay, cosine is to the right. Okay, so cosine is horizontal, so it's positive. Okay, we've actually been given that. And so we need to work out the tan ratio. The tan ratio, okay, it looks like negative slope. In fact, it's negative root 39 over run of 5. There's my slope. And notice I'm keeping it an exact value. Okay, that's very important. Keep in exact values. Now we're going to solve for theta. So when I solve for theta, and I'm going to call it theta 1 because my calculator always gives me theta 1, I'm going to use the arc cos. So here I've been given the ratio. I need to actually go backwards and solve for the angle. So I'm going to use the second function cos. My input is my ratio. My output is going to be my angle. So when I work this out, I end up with second cos 5 divided by 8 equals 51.32. So theta 1 is equal to 51.32 degrees. And when I look at that angle there, that looks, yeah, it looks reasonable. The problem is 51.32 degrees. Remember, this is all about position. Where's the position? What point does that locate? Well, unfortunately, it's not locating the right point because it's in quadrant 1. Okay, it's locating that point here. So that angle is 51.32 degrees. That's a quadrant 1 angle. That's not the one I'm looking for. I'm looking for the quadrant 4 angle, which is this angle measured all the way around to here. Now my calculator is not going to give this, but remember that there are two possibilities I have to consider. The first one doesn't work. I know the quadrant, so it must be the other one. Okay, so this is where I'm only going to give one solution because the quadrant is known. The location, specific location between these two is known. So theta 2, okay, I can go negative 51 degrees. That might be the easiest one to do, negative 51.32 degrees. That's the right position. Or you can go 360 minus that and go 300 and what's that going to be? 308.68 degrees. Okay, so if I go 308.68 degrees, I'm going to end up in the same position as negative 51.32. So these both are correct solutions, and those are coterminal.